see you there. So glad you could join me today. I'm going to be telling you a story about a little tadpole with big dreams. And like any good story, it starts with once upon a time.
What does DOS do? A tadpole's journey. Once upon a time, in a pond far, far away, there lived a small tadpole named Chad the Tad. Now, Chad was a curious tadpole who had big dreams and lots of questions. But unlike his friends who were worried about big, scary issues like climate change, deforestation, and pollution, Chad wanted to find a question that he could answer himself, one that nobody had asked before. And that's when he thought of dialysyl sodium sulfosuccinate, or DOS. Chad had heard of DOS, an anionic surfactant that was present in so many things from oil spill cleanup chemicals to food and household products to pharmaceuticals and cosmetics. And he wondered if DOS is in so many different things and could end up in his environment through wastewater or other means, how will that affect him? Specifically, could DOS be acting as an endocrine disrupting chemical? Chad knew that he was in a unique position to study DOS as a potential endocrine disruptor because he is a sensitive indicator species that uses the thyroid hormones T3 and T4 to kickstart metamorphosis. So he decided to embark on an adventure to answer his big question. Does DOS disrupt thyroid hormone signaling in the bullfrog? First, metamorphosis was induced using thyroid hormone injections, and then he was exposed to low, medium, and high DOS concentrations that were chosen to be between the aquatic life benchmark and the FDA-approved levels for human consumption. Then RNA was isolated from both the tail fin and liver tissues, and finally, the expression of 3 thyroid hormone responsive transcripts, thyroid hormone receptor alpha, thyroid hormone receptor beta, and thyroid hormone-induced basic leucine zipper containing protein, or THB-ZIP, were analyzed using qPCR. By looking for changes in the expression levels of these thyroid hormone responsive transcripts, Chad could determine if DOS disrupted the thyroid hormone signaling that is so critical to his metamorphosis. As you can see in these tables, Chad found that DOS-induced changes vary depending on the tissue, the gene transcript, or the thyroid hormone treatment, and also DOS concentration. Overall, Chad's quest for answers led him to the conclusion that DOS showed endocrine disruption of thyroid hormone signaling during tadpole metamorphosis, but his journey won't stop there. DOS is surprisingly widespread and will continue to enter the environment through human consumption. So understanding DOS's influence as a potential endocrine disruptor is key.